All right, these are the answers to our worksheet for functions. First part here just gives you some information about functions. There's nothing really to do up in here. It's just kind of read it if you'd like. When we get down here, and it says the function f of s equals 8s plus 15 represents the cost of ordering s shirts, or the domain in the range of the function. Well, the domain is your s, right? Your domain would be the shirts. And so I would say anything positive, right? You can order 1, 2, 3, 4, and as many shirts as you want. The range then would be the cost. And if you order 1 shirt, that's going to be $23. 2 shirts would cost $31. So, you know, it would be the different cost, I guess, is what I would say. So if you wanted to actually put numbers to it, for the domain, it would be 1, 2, 3, 4, and so on. And then for 1 shirt, like we said, it would be $23, $31 for 2, $39 for 3, and then so on, like that. Okay. Now we're going to use that function to actually find some of these values. So f of 7 would be 8 times 7 plus 15. That's 56 plus 15, which gives us 71. Okay. So you order 7 shirts, it's going to cost you $71. If you order 100 shirts, and go 8 times 100 plus 15, that's 800 plus 15, which is 815. Okay. If you order 11 shirts, it's 8 times 11 plus 15, it's 88 plus 15, which is 103. Okay. If you order no shirts, now this is where it gets a little silly, because it's 8 times 0 plus 15, which is 0 plus 15, which seems to suggest that 15, but really there is no idea. Like, we can't really order 0 shirts in the context of that, but just using that function straight up, that's what we would get. Same thing with 2.5. You can't really order 2.5 shirts, but 2.5 times 8 is 20, and 20 plus 15 gives us 35. So those are the values we get for the function, but really these are the only 3 that kind of make sense for what we're talking about. Now, calculate the value of x, which makes each equation true. Now we want to know, when would we get a cost of 55? How many shirts would that be? So we're going to set that equal. We're going to subtract 15. 40 equals 8s. Divide by 8. And we get s equal to 5. For 175, same thing. All right, 8s plus 15. Subtract 15. 160 equals 8s, and divide by 8, we get s equal to 20. And then here, 151 equals 8s. It's the same thing, right? We're just subtracting 15. So 136 equals 8s, and divide by 8, which gives us 1, and then 56, 17, I think, is what we get for that. All right, so that's that page. Then the next page gives us a table and then asks us for h of different values there. So when it says h of 7, we go to 7 years, and we see that that was 49. H of 1.5, well, that's 18 months, 1.5 years, that's 34. 11 years was 57. And then 12.5. We'd have to kind of estimate there on 12.5, that's halfway between 12 and 13, so halfway between 59 and 61 would be 60. Okay. Now they want to know what at what age are these the average heights. So 61 was for age 13, 53 was for age 9, 36 was for age 2, 45, we're going to have to take a guess on that one, right? 45 is between 44 and 47. So if you said, 5.25, 5.5, 5 1/3, something in there. It's between 5 and 6 years where that happens. Okay. All right. Now, off of a graph, when it says d of 2, we go to 2, and we look for the height. And the height at 2 was 4. Okay. 2.9. The height was still 4. At 5, the height was 11. And at 10, the height was 0. Okay. So for these ones here, now they want to know when is the height these. So we were at a height of 2 at time 1 and at about 9.5. We were height of 4 from 2 to 3, and then again at like 8.75 or however you estimated that. We were at a 5 at 4, and then again at about 8.5. And then we were height at 0 at 0 and at 10. So these, you're just looking for the actual height. When were you at these spots there? Okay. All right. Then we get this worksheet here. And it gives us, again, some more information if you're curious. But for these, we're just plugging these in. So this is 2 times negative 2 minus 3. That's negative 4 minus 3, which is negative 7. This is 2 times 7 minus 3. 14 minus 3 equals 11. 2 times negative 4 minus 3 is negative 8 minus 3, which is negative 11. Okay, pretty simple. Same thing here. Negative 7 times 0 plus 1 is 0 plus 1, which is 1. Negative 7 times negative 1 plus 1 is 7 plus 1, which is 8. Negative 7 times 5 plus 1 is negative 35 plus 1, which is negative 34. Okay, not too bad. When there's multiple x's, we're putting them in both of those. So for this one, this is negative 3 squared minus 3 times negative 3 plus 5. That's 9 plus 9 plus 5, which is 23. For this, it's 5 squared minus 3 times 5 plus 5. That's 25 minus 15 plus 5, which is 15. Negative 2 squared plus 5 times negative 2 minus 3 is 4 minus 10 minus 3, which is negative 9. 1 squared plus 5 times 1 minus 3 is 1 plus 5 minus 3, which is 3. Now for this one, what we're doing is we're plugging these in, and then we're going to say what kind of function we get. So if I put negative 2 in, it's negative 10 minus 3, which is negative 13. Put negative 1 in, I'm going to get negative 8. Negative 3, 2, 7, and 12. All right? If you were to graph this, what you're going to see is you got a line that starts at negative 3 here, goes up 5 over 1. We could have predicted that from the equation. 5x minus 3 is a slope-intercept form. So what's kind of this? This is the line. Slope 5, y-intercept. Pardon me. Sorry, my contraption fell there. Sorry about that. Line slope of 5, y-intercept of negative 3. Okay, so that takes care of that one. And then the last page here, we're putting these in. You should have gotten 5.25 for that, 5.5 for that, 6 for this, 7. Then this one would be 9, and then this one would be 13. That one function is going to go kind of like that. This is what's called an exponential function. Don't worry about that. We'll talk more about those later. Okay. F of negative 3, if I find negative 3, that's equal to 2. F of 20 was equal to 0. F of 8 was equal to 4. F of negative 1 is not on there, right? So that's a mystery. We don't really know what that equals. We do know that the function equaled 9 when x was 2. It equaled 4 when x equaled 9 and 8. It equaled 0 at 20. And negative 5, again, is a mystery. We don't have a negative 5 for that. Okay. So now down here, they give you a function. They want to know when it equals this. So this is the time where we set it equal. Add 3 and divide. All right, and we get x equal to 9 for that. Here we set it equal. Subtract 2 and divide. Get x equal to 3. Here we set it equal. Add 7. Divide. Get x equal to 7. And then here set it equal. 1.5 divided by -2. We get x equal to 10. All right. Hopefully that was good for you.